In this video, we will introduce the sample data warehouse we'll use in our project. First, let's bring up the SQL developer. Double-click the SQL developer icon on the desktop. Click the dev db1_sh connection we created earlier. Now we have connected to the sh schema. This is a sample data warehouse schema that was created during the Oracle database install. This schema is a simple data warehouse structure. However, it has enough features and data sets to implement a BI demo project. Building a data warehouse from scratch is a course by itself. Using the sample schema will help us speed up our learning on OBIEE. We introduced the data warehouse and dimensional modeling theory in the last video. Now let's apply the theory with a real database. Let's review the star schema ER diagram once more. Remember the fact and dimension tables and their relationships. Now in SQL Developer, expand the table module. The listed tables forms a simple data warehouse. The tables of interest are the fact tables, costs and sales, and the dimension tables, channels, countries, customers, products, promotions, times. We can ignore the other tables for this study. Click on the sales table. The sales table has the following ID columns: channel ID, custom ID, prod ID, promo ID, time ID. These are foreign key columns to channels, products, customers, etc. The quantity sold and amount sold columns are measures. These are the numeric data we will aggregate. Click Data tab to display the data view. In order to understand the data in the fact table, we can try to describe one row of data in plain English. For example, this line. Product 13 is sold to customer 987 through channel 3 with promotion 999 on January 10th, 1998. The quantity sold is 1 and the amount sold is $1,232.16. This sentence describes the granularity of measure or fact. It determines the level of detail the data is recorded. Right-click inside the data view, select row count. The sales table has nearly 1 million rows representing many years of sales transactions. The common fact table characteristic is many rows. In a report, we can summarize the sales data through grouping attributes of dimensions. One fact table is able to answer many questions regarding sales, giving a combination of dimensions. Let's look at the dimensions. Click on the products table. Check the row count again. There are 72 rows. Generally, the dimension table has far less data than the fact table. The products table has a long list of columns. The common dimension table characteristic is many columns. As you see, these columns are mostly descriptive text columns. We have prod name, prod description, prod category, prod subcategory, and so on. These columns are what the user would use to filter and group facts for summarizing. Let's check the customers table. There are 55,000 customers, and there are many descriptive columns for the customers too. One thing to look at here is the country ID column. It is a foreign key to the countries table. Click on the countries table. We see the countries and their regional description columns. A customer lives in a country and a country belongs to a region. This is a variation of the star schema called a snowflake structure. It allows 2 or more levels of joins from the fact table. In order to summarize sales amount by region, the report query will join sales to customers first, and then join the customers to countries table. The region attributes is in the countries table. Next, click on the times table. This table has all the detailed description of individual dates. It has year, quarter, month, week, date descriptions. It also has calendar and fiscal dates attributes. This is a typical time dimension found in most data warehouse designs. Summarizing data by different levels of dates is a universal practice in all businesses. You can continue to visit the costs, channels, and promotions tables. Another object we need to check is the Profits view. Expand the View module. Click on the Profits view. Click on the Data tab. This looks almost the same as a sales table. The view combines sales and costs into one virtual fact table. The view has the same dimensionality but with more measures. We will not worry about the code composition behind this view. Just think of it as the same sales table with more measure columns. The additional measures will give us more data to work with. We'll use this fact view in our project. With the data elements in mind, imagine this data warehouse will support reporting on sales. Users may want to ask analytical questions like, can I compare the yearly total sale amount in each region in the past 4 years? What are the top 10 products that have the most sales amount in each sale channel? Which country has the most number of customers and average sale amount per customer in that country? You can try to brainstorm how you query these tables and summarize the data. Even if you are not familiar with SQL, you can try to think how you will retrieve the necessary data manually to answer these questions. This mental exercise should help you to pull the data together to see how a common approach is used when answering these many different questions using this dimensional structure. It also helps to understand how BI systems make all the human effort automatic. Understanding the data is a foundational prerequisite for BI development. You probably will not develop and test the BI project correctly if you do not know your data well.